Hello, you're welcome. How to solve this nice algebra equation? Solution from here. From what we have here, we can multiply this directly. 6 times 6, we can express that as 6 squared. Then over x times x, also that's x squared. Then equals to, on this side as well, x times x, that's x squared. Then over 6 times 6, we have 6 squared. The next step here, we cross multiply. That is 6 square multiplying 6 square. And also equals to x squared times x squared. Then next step here, we can also write this. Same thing multiplying. When we have a times a, this same thing as a squared. Then also here we can write this as 6 squared then all squared. That equals to also x squared all squared. The next step here, we take the right hand side to the left hand side. And what we have becomes 6 squared all squared minus x squared all squared, then equals to 0 from here. Then from here, this follows difference of two squares. When we have a squared minus b squared, which can be written as a plus b into brackets, then open bracket a minus b. As this here, a is standing as 6 squared and b standing as x squared. Then what we have here follow this and becomes 6 squared plus x squared into brackets, then also open brackets 6 squared minus x squared close brackets, which is equals to 0 from here. Then here we have two possible cases. The first one, 6 squared plus x squared equals to 0, or we have 6 squared minus x squared equals to 0 here. Then write this as x squared plus 6 squared equals to 0 here. Then this follows when we have a squared plus b squared, which can be written as a plus bi into brackets, then open bracket a minus bi. Then here, what we have follow this and becomes x plus 6i into brackets, then open bracket x minus 6i close bracket, which is now equals to 0 from here. That is, here we have two possible cases. The first one, x plus 6i equals to 0, or we have x minus 6i equals to 0 here. And here, this becomes x equals to minus 6i, which is a complex solution here. Then here we have x equals to 6i, which is also a complex solution here, making two complex solutions from here. Then solving from the second case here as well, that is 6 squared minus x squared equals to 0 here. Then this also follows when we have a squared minus b squared, which is same thing as a plus b into brackets, then open bracket a minus b. That is, here, this becomes 6 plus x into brackets, then also open bracket 6 minus x close brackets, then equals to 0 here, which implies we have two cases as well. 6 plus x equals to 0, or we have 6 minus x equals to 0 here. Then when we solve this, we have x equals to, taking pluses to this side become minus 6. Also, we have a real solution here. Then on this side, we take minus x to that side become plus, which implies 6 equals to x, which is something as x equals to 6. Also a real solution here. And we have two real solutions and two complex solutions here. That is, when we write it out together here, we have the first solution. We can call that as first resolution, that's 6. Then the second solution, x2, we have minus 6. The third solution, x3, we have 6i. And the fourth solution, s4, we have minus 6i. So altogether here, we have 2 real and 2 complex solutions here. Then we can check if this will satisfy this given problem. That is, we substitute the value of x into what we have here. And the first one, x equals to 6. This becomes 6 over 6 times 6 over 6. Is it equals to, also here we have 6 over 6 times 6 over 6. And 6, this is 6. And 6 over 6 here, same thing as 1 times. Also 6 over 6, that's 1. Is equals to this side as well, 6 over 6, that's 1. Then times 1. And 1 times 1 here, that's same thing as 1. Which is equals to 1 times 1 here, also 1. Then left hand side equals to the right hand side. And hence, x equals to 6 satisfy this given problem. Then also, we substitute x equals to minus 6. That is, this equation becomes 6 over minus 6 times 6 over minus 6. Is it equals to minus 6 over 6 times minus 6 over 6? Then 6 over minus 6. I write that as minus 1 times also minus 1 is equals to minus 6 over 6. That's the same thing as minus 1 times also minus 1. And minus 1 times minus 1 become plus 1. So we have 1, which is equals to also minus 1 times minus 1 become plus 1. And hence the left hand side equals to the right hand side. And therefore, minus 6 also satisfies this given problem. Then, for x equals to 6i, we substitute as well. And this equation becomes 6 over 6i times 6 over 6i. Is it equals to 6i over 6 times 6i over 6? And 6 over 6i, we can write that as 1 over I, then times also 1 over I. Is it equals to 6i over 6, same thing as I times also I. Then here 1 times 1, that's 1 over I times I, that's I square. Is it equals to I times I, that's I square. And we should note that I square, same thing as minus 1. That is, here we have 1 over minus 1 is equals to minus 1. Then 1 over minus 1 is minus 1, which is equals to minus 1 here. Left hand side equals to the right hand side. Then also 6i satisfy this given problem. Also we substitute x equals to minus 6i. That is, what we have here becomes 6 over minus 6i times 6 over minus 6i is equals to minus 6i over 6 times minus 6i over 6. Then 6 over minus 6i, I write that as 1 over minus I times also here 1 over minus I. Is it equals to here? We can write it as minus I times minus I. Then here 1 times 1, that's 1. Then over minus I times minus I become plus I square. Is it equals to here? Minus I times minus I, that's also plus I square. Which implies I square is minus 1. Then we have 1 over minus 1. Is it equals to minus 1? And And 1 over minus 1 is minus 1, which is equals to minus 1. Also, left hand side equals to the right hand side. Hence, minus 6r also satisfies this given problem. And thank you for watching. Don't forget these steps. Subscribe for more videos and turn the notification bell on. Share this video, give it a thumbs up and put your comments. See you next class and bye for now.